In question 1a, we need to give in words the relationship between the force acting on a body and the momentum of the body. Well, force equals rate of change of momentum. In B, we have a container on a top pan balance measuring mass in kilograms. A funnel holds some sand. The sand falls at a rate of 0.300 kilograms per second into the container, having fallen through an average height of 1.60 meters. In part 1, we need to show that the velocity of the sand as it lands is 5.6 meters per second. Well, by the conservation of energy, the gravitational potential energy at the start will equal the kinetic energy at the end. So mg delta h, the potential energy at the start, is mv squared over 2, the kinetic energy at the end. Rearranging for the speed, putting in the values given in the question, gives 5.60 meters per second as shown. In part 2, we need to find the magnitude of the momentum of the sand that lands in the container each second. Well, momentum is mass times velocity, and every second we have 0.300 kilograms landing at 5.60 meters per second, a momentum of 1.68 kilogram meters per second. In part 3, we're given the mass of the container at 0.650 kilograms and asked to show that the reading of the balance 10 seconds after the sand starts landing will be 3.82 kilograms, assuming the sand comes to rest without rebounding. Well, after 10 seconds there will be the mass of the container, the mass of the sand, and the reading due to the change of momentum of the falling sand. The mass of the container was 0.650 kilograms. We've had 10 seconds with 0.300 kilograms landing per second. The rate of change of momentum of the sand was 1.68 kilogram meters per second found earlier. This is a force, effectively like a weight, and therefore if we divide it by the acceleration due to gravity, we'll convert it into a mass in kilograms, and this gives 3.82 kilograms as required. In part C, we're told it takes 20 seconds for all the sand to fall. On the axes, we need to sketch a graph to show how the reading of the balance will change over a 30-second period, where t equals 5 seconds is the time at which the sand starts to land. No further calculations are needed, and values need not be shown on the vertical axis. Well, first we would have the mass of the container, which I'll put here. The mass would not change initially over this portion here. Then there would be the sudden impact of the sand, giving an immediate rise in the reading. The mass of sand would gradually rise over the next 20 seconds. Then when the sand stopped falling, we would lose the force due to the sand, and we would then have a new higher constant reading shown here.